Hello, good day class. How are you doing today? All right. So without taking our time, we are going to look at physics today. And the topic we have on the board here is reflection of light on a curved surface. Reflection of light on a curved surface. And the objective we have for this class is that at the end of this lesson, you'll be able to distinguish between types of curved mirrors, parts of a curved mirror, also know the formation of image on a curved mirror, also look at mirror's formula and also the practical problems on a curved mirror. So without taking time, we are going to first of all recall what we have done so far concerning reflection. In our previous class, we say that reflection is the throwback of light on a what on when it hits an obstacle. So, and last class we treated reflection of light on a plane mirror, and we already know that when just like the mirror we use at home, when rays of light falls on it, it reflects back into your eyes. So today we are going to see how rays of light can be reflected on a curved mirror. So first of all, we're going to look at types of what curved mirrors. So looking at the types of curved mirrors, we have basically two types of curved mirror, and they are one, concave mirror, two, convex mirror. We need to know how these mirrors can be formed. So assuming we have a sphere, just like I have on the board here, and I decide to cut out a portion of the sphere, and when I cut this sphere, I'm going to have just this I have here. So this is the part of the sphere. So a mirror, a curved mirror actually forms a part of what? A sphere. So now, when this mirror is coated either in or outside, then that is where the names of the types of mirror comes from. So when we coat this mirror inside, just like I have it will have the ability to reflect light as a it will have the ability to divert the rays of light that will fall on them. But when I put it inside, just like I have this, okay, outside now, and rays of light falls on this surface, it will have the ability to converge what? Light. So this one that has the ability to diverge rays of light is what we call the convex what? Mirror. Is what we call the convex what? Mirror. So when rays of light, this is our principal axis. When parallel rays of light falls on it, whenever we have parallel rays of light, we consider rays of light that's coming from a far distance falls on it. What will happen is that it will converge these rays of light at the same side the parallel rays of light are coming from. And the point where all these rays of light meet is what we call the principal focus of a mirror. So that is labeled with F. So also talking about the concave mirror is quoted behind. So when we have the principal axis and we have parallel rays of light that are falling on them, what happens is that these parallel rays of light, okay, this is the one we just talked about. So we have this falling rays of light falling on them. It will have the ability to diverge the rays of light, and this is the direction of the parallel rays of light. So when it comes on it, it will do what? It will diverge. And when they are diverging, it will now seem as if they are diverging from a point behind what? The mirror itself. So this is what we're going to have. So these are the reflected what? Rays of light when they falls on a convex what? Mirror. So take note of that. As you watch the video, you can pause the video, take notes, and then you can rewind and continue as well. Alright, so having known the difference between these two mirrors, it is very, very important that we should look at the parts of what? Of the two, any of the two mirrors, because the parts are still the same. Alright, looking at the parts of it, We are going to use the concave mirror as an example. Alright, so the concave mirror, remember, is quoted at the back of the mirror itself. So when we have higher rays of light, okay, now, first of all, the first thing you need to know about this is the point on the reflecting surface, which is also it passes through the principal axis. We call that point the pole. We call it what? The pole. Then there is a distance measured from the pole to a point, which we call the focal length, and that point is called the principal focal, just like I talked about before. Then I have another point, okay, I have another point in front of this, which I can call C, which we are going to call the what? The center of curvature. Alright, now looking at this, I'm going to label here A, then B. Talking about the parts of a mirror, these are the things that you will see. First of all, I talk about the pole. Then the next thing I talk about the principal focus and the what? The center of curvature. I'm going to explain all these things one after the other. But I want you to know that before I continue the explanation, that the distance from the pole to the principal focus here is called the focal length, just like I said before. Then distance from the pole here to the center of curvature is called the radius of what? Curvature, and it is denoted with what? The small letter what? R. Alright, now taking this one after the other. The first one, AB, that's this length AB here, is called the what? The aperture. Now what does it mean? It simply means the width of that what? Mirror into consideration. The width of the mirror into consideration. Then after that, we have the pole. The pole is a point on the reflecting surface. The pole is a point on the reflecting surface, just like you have it here. This point is called the pole. It's a point on the reflecting surface, which also where the principal axis does what? Passes through. This line that we have here is called the principal axis. Alright. Then we talk about another point, the principal focus. This principal focus is a point on the principal axis. And this is a point on the principal axis where all the rays that are parallel or close to the principal axis itself happens to diverge from or converge after reflection. Happens to diverge from or converge after reflection. Now, when we say happens to converge, it is applicable in a concave what? Mirror, where the mirror itself has the ability to do what? Converge what? Rays of light. Then when we say happens to diverge from after reflection, we are talking about a convex what? Mirror, whereby the point seems to be behind the mirror itself, and it now happens that the rays seems to be coming from that. But we cannot use this particular one to show you because this is a concave what? Mirror. Now, talking about this point, this particular C here, we call it what? The point, the what? The center of what? Curvature. The center of what? Curvature. Now, the center of curvature here simply means the center of the circle for which this particular mirror itself forms a path. Remember that this particular thing was actually cut out from here, the circle, right? So it is the center of the circle for which this portion of the mirror forms what? A path. That is what we call the center of what? Curvature. Now, the distance between the pole here and F here is called the focal length. It's a distance, it's a length. So distance between P, which is the pole, and F, which is the principal focus, is called the what? The focal length. While the distance between the pole and the center of curvature is called the radius of curvature. The distance between pole and the center of curvature is called the what? The radius of what? Curvature. Now, what is the radius of curvature? The radius of curvature R is the radius of the circle of which this particular mirror forms a part. The radius of the circle of which this mirror here forms what? A part. Because we remember that this mirror was cut from what? A circle. Alright. Now, there are other relationships which we need to know. And one of those relationships is that from theory and geometry, we found out that F rather is equal to R divided by what? 2. Remember that F here, small letter F here is our what? Focal length. While R here is our what? Radius of curvature. So meaning that 2 times F is the radius of curvature. So we can say that R is equal to 2F. So meaning if you know the radius of curvature of a mirror, I mean curved mirrors, you can find the what? The focal length. But if you also know the focal length, you can also find the what? The radius of curvature. I hope you understand that. Alright, so let's move ahead. Our next objective which we must learn today is what we call formation of image on a curved mirror. What do I say? Formation of image on a curved what? Mirror. Now, it is important you should know that these two kinds of curved mirror we are talking about, the kind of images that are formed on them are not the same because of the fact that they don't have the same kind of ability. The other one has the ability to do what? Diverge rays, while the other one has the ability to do what? Converge rays. Now, the one that has the ability to converge rays is the one we are going to talk about. Now, I'm going to give a simple summary between these two kinds of mirrors. And what is that? I want to say that the property of image that is formed by a concave mirror changes as the distance of the object changes from the in front of the mirror. So meaning when you vary the position of the object, the properties of the image you will have will also do what? Vary. Take note. And when we talk about properties here, we mean the nature of the image, the size of the image as well. So this is what we mean by the what? By the properties. But for convex mirror, irrespective of the position of the object in front of the mirror, the properties of the image remains the same. It has the same kind of property no matter where you position the what? The object in front of the what? Mirror. So meaning that the property remains constant for any position of what? Object. Now let's dive into it. Let's quickly dive into it. So looking at the formation of image, by a concave mirror. And what do we say? We say that the properties of image formed by a concave mirror varies as the object distance vary in front of that was mirror. So, but before we go into that, or we know the properties, it is important you should know what we call the ray diagram, because it's only through the ray diagram that you can easily practice this and even know them in the tips of your fingers. So it is important you should understand the ray diagrams. And for you to understand the ray diagrams, you must know the three particular type of rays that are important in drawing the ray diagram. In drawing the ray diagram, we use three special types of what? Ray. And you know that when there are reflections, when the rays, reflected rays intersect, it forms what? An image. Now, I'm going to illustrate that now. This is a concave mirror. Remember, we are talking about a concave mirror. So, remember that there are four properties I mentioned before, which is the principal focus and the what? The center of curvature. Here remains the what? The pole. Now, like I was saying before, if I have an object placed here, the properties of the image will not be the same when it is here, and it will not be the same when it is here. It will never be the same when it is here. It can never be the same when it is same, and it can never be the same when it is as far distant, which we regard as what? Infinity. So, and we say that for us to be able to know the properties of this image, we must have to know how to draw the ray diagram. And the ray diagram must be drawn using three different kinds of ray. But if we have only two that intersect themselves, it is enough for us to form an image. So, quickly doing that, I'm going to consider an object between the principal focus and what? The center of what? Curvature. Now, the first ray, which I call ray 1, is the one that moves parallel to the principal axis. And after reflection, it now diverges, or rather, it now passes through the what? The principal focus. That's ray 1. Anytime you have a ray that moves parallel to the principal axis, after reflection on the reflecting surface of the curved mirror, it must pass through the what? The principal focus. That's ray 1. The second ray is the one that passes through the principal axis, and immediately it strikes this mirror, it reflects and now travels what? Parallel to the principal axis. So what are we trying to say? You notice that it is almost like opposite of the first one, because the first one travels parallel and reflects through the what? Yes, principal focus. Then the second one travels through the principal focus and travels parallel. So these two is even enough for us to obtain an image. But there is another one. And that one is the one that passes through this point, which we call the radius of what? Curvature. And I have said it before that whenever we have a ray, okay, let me mention it now, that whenever we have a ray that passes through the center of curvature, it hits the mirror itself and it comes back it comes back through the same point. So ordinarily, this is what our image would have been. No, this is not drawn to scale, but this is what we are supposed to have. In the sense that three of them will do what? Intersect at where? At a point. And where there is intersection of ray of light, that is where image are formed. So this is the kind of image we are going to do what? Have. So these are the ray. I call this one ray 1, I call this ray 2, and I call this ray 3. I'll recap. Ray 1 is the one that travels parallel to the principal axis and passes through the what? Principal focus after reflection. Ray 2 is the one that travels through the principal focus and travels parallel to the principal axis after reflection. And ray 3 is the one that passes through the radius of curvature, sorry, the center of curvature. It hits the mirror and at 90 degrees and does what? Without deviation, it comes back through the same path. And when it comes back to the same path, all of them will all intersect at a point. And when they intersect, an image will be formed. This is very, very important. So master these three rays and use them. Two is enough for you to draw the image, just like I've said before. So as we go along, you will appreciate and see what the properties of images will look like when we begin to change their position as we go ahead. Okay, the first one we are going to consider is when object is between pole and the what? Principal focus. So object is between, I will call it P and what? F. Remember we have been using this before for some time now. This is the principal focus. Sorry, this is the pole and this is the principal focus. Alright, so let's have our principal axis. Let's have our mirror, which is a concave mirror. So this is our O, this is our F, and this is our C. So when we have an object placed at this position, remember, the first ray, which is ray 1, is the one that will travel parallel to the what? Principal axis. And the next thing that will happen is that it will pass through the what? Principal focus. You see that? That's ray 1. Then ray 2, we are going to have the one, this one here, that will pass through the head of this, just like we have said before, which is ray 3. Now, I want to say something here. We cannot draw ray 2 here, which is the one that passes through here, because of some reason. So this and this are enough to draw this ray diagram. So we have this. So the one that travels this way hits this at 90 degrees and comes back at the same. Now, when we look at this, you see that this thing can never form an image at this side because they look as if they are diverging away, right? But meaning that the other side, they could be intersecting, but maybe at somewhere very, very well. But I want you to know that whenever we have anything that will form behind the mirror, we use dotted lines to denote that. So when we have this, can you see that? You see that the image seems to fall behind the what? The mirror itself. So here we are going to have the image is also going to be a dotted line because it is a virtual image. Remember the last class we talked about real image and virtual image. The ones that can be caught on a screen and the ones that cannot be caught on a screen. The ones that can be caught on a screen is real image, while the ones that cannot be caught on a screen is called the virtual image. So you see, just like when you look yourself through the mirror, on the plane mirror, you will see yourself, but you cannot catch yourself on that behind it. The same thing happens here too. So we see that if we're asked the properties or the features of this image that are formed, first of all, we can talk about the nature. Remember I told you what the properties are? What is the nature? The nature is that, first of all, it is erect. If you can see that, right? Is it also? And what? It is also what? Visual. That's one. Then secondly is the size. What can you see about the size? The size, is it bigger than the object or is it smaller than the object? This is the object, this is the image. The size is bigger than the object. So we say that it is what? Magnified or enlarged. Then finally, the position, because these are the things we talk about the properties. The position is just for us to talk about where the image is formed. The image is formed behind what? The mirror. Behind the mirror. Please, you can pause at this level, take the notes and put down the properties so that we can go into the next one. Alright. So the next one we are going to look at will be when object is between. Now it is shifting from between P and F. Now it will be at F now. Is at what? F. Is at F. So when object is at F, alright, these are F, these are C. Alright? So when object is here, the same rays, 2, like I said, is enough. So first of all, we have a ray parallel, which will now do what? Pass through the principal focus after reflection. Then the second one is the one that will pass. Now, because of the fact that this particular object is at F, we cannot draw a ray diagram, a ray that will pass through here. It's not possible. So it will be very difficult for us to do. So the next one we are talking about is this one. This one that passes through the center of curvature, hits the mirror, and it now returns back on the same path. Now look at what we have. Do you notice something? You notice that these rays are parallel, right? So, and you know that two parallel lines can never meet. They can never meet. And in physics, we regard such image that will be formed because at infinity, we regard it as infinity because we know that this particular thing will form at a very far distance. As a matter of fact, you might not be able to discover the properties of the image that are formed here because of the fact that you cannot capture the image at infinity. But then, in real reality, just a distance that is far can be taken to be at where? Infinity. So, there are some exceptions. Now, let's take down the properties of the image. First of all, what is the nature of the image? I want to say something here, which I will also come back to it to reaffirm it at the end of our class or if not this section, maybe another section. The nature of this is that one, ordinarily we cannot even define the nature of this. But then we can say that the nature includes that it is real and it is inverted. I will still explain this when we take the last one so that you see the reasons for this. Then size, it is what? Enlarged. It is enlarged. Then the position, where did it form? It forms at where? At infinity. Infinity, whenever we say infinity, it simply means a very far distance, a very far what? Distance. So you can just take note of it. Then let's dive into the next one because. Alright. So the next one we're going to look at is when the object will now shift between F and C. Objects between F and C. When object is between F and C, this is what we're going to have. We have our F, we have our C. So object is located somewhere here. So we have the first ray which travels parallel and it will now reflect through the principal focus. Now the next way we're going to have is the ray that travels through the principal focus, right? And what happens next? It now passes through parallel to the what? Principal axis. Then if we want, we can draw the third one, but if we don't want, then we know this since we have an intersection of rays already. So we have this as this. So we are going to form an image. This is our object here, and this is our image. What can we say about the properties of this image? The nature of this is that if you look at it, you see that it is inverted. This one is up, this is down. So it is inverted. Or rather, let me start by saying it is real and it is also inverted. It is real and inverted. Real in the sense that it forms in front of the what? Mirror. But remember the one that formed behind, you say it is what? Virtual, yes. So it is real, it forms in front of the mirror. It is inverted, just like we are seeing, to compare to the object. Alright, so the next thing is the size. What's the size? Looking at this and this, you see that this image is bigger than the object, right? So we say that it is what? Enlarged. It is enlarged. So finally, what's the position? The position is between F and, sorry, is beyond C, right? Beyond C. Beyond C. That is the position. So you can pause the video, take the notes of this, so that we can now take the remaining two I will have. Alright, so the next one we'll take a look at is when object is beyond C. Object is beyond C. Oh, it's at C. We've not taken that. It's at C. You know what C is, right? Yes. C is the center of what? Curvature. Alright, so we have our principle as this. We have our mirror, concave mirror. We have our F. We have our C. Then I have my object here at C. So I'm going to have the ray that travels parallel. And the next thing is that it will pass through the what? Principal axis. That's ray 1. Ray 2 is the one that will pass through the principal focus, right? And now travels parallel to the what? The principal axis. Is that okay? So now, if you look at this position, you see that this is the point where the intersection occurs. So, and when we take it from there, we see that the image forms at the same place. It forms at the same place. Now, if we look at this very well, we can easily obtain the properties of the image. The nature of the image is that, look at it, is it real and inverted? Yes, it is real and inverted. Real because it forms in front of the mirror. Inverted because it's moving in opposite direction with the what? Object. So we say that the nature is that it is real and inverted. It is real and inverted. So what can we say about the size? That's funny. The size is the same. Yes, it's the same. They are the same size. Same size. Same what? Size. Alright, the position Where is it located? From what we've seen here, located at C. At C, which is the center of what? Curvature. This is a great phenomenon. All right, so just pause it, take note of it. Let's take the others. Now, we are going to consider when object is beyond C. When object is beyond C, these are mirror, these are F, and these are C. So beyond C means is above, like the distance from the pole is more than the radius of curvature. So first of all, we have parallel rays. We have the first ray, which is parallel to the what? The principal axis, and it now passes through the principal focus after reflection. That's the one. Ray 2, we can still have this. The one that passes through the principal focus, and then now does what? Travels parallel. I need to make a better straight line for this. Sorry for that, but let me just make a better straight line so I can have a nice intersection. Remember that distance from the pole to F must be equal to distance from F to what? To C. That's the first thing you must have to do. So we have this parallel to the principal axis, then travels through the principal focus, then passes through the principal focus and travels what? Parallel to the principal axis. We can have the third one, but the two alone is enough for us to do what? Form an image because they have already intersected. So we can draw our image here. So this is our image, while this is our object. Now talking about the properties of this, we have the nature. The nature here is, yes, it is still real and it's also inverted. Real because in front of the mirror, inverted because it's in opposite direction with what? The object. So we say that it is real and inverted. It is real and inverted. Then secondly, we talk about the size. What's the size? If you look at this very well, you see that if you measure it, you see that this object is bigger than the image, right? So what do we now say that the image happens comparing to the object? We say that it is diminished. It is diminished. So it is diminished. So meaning that it's smaller than the what? Object. Then finally, what's the position? It is located between F and C. Between F and C. Between F and C. So those are the properties of what? The image when object is located beyond C. So first take note of it. So we can take the last one. Alright. Taking down the last one, that is when object is at infinity. When object is at infinity, these are F and these are C. Now in physics, whenever object is coming from an infinity, we use parallel rays of light, parallel rays of light, parallel rays of what? Light. Because we cannot locate infinity on this board. So we use parallel rays of light to do that. And if we are doing that, remember that ray must pass through the what? The principal focus and the what? Center of curvature. So if we have that, we're going to have a ray that passes through the principal focus here and also passes through, which are parallel. You can see that? So this is parallel rays of light. And when these parallel rays of light hit the mirror, this one will now do what? It will now travel what? It will now travel parallel to the what? The principal axis. I mean the one that passes through F. So this is what we are going to have, right? Or let me make it straight. Remember, it should be a straight line to travel parallel to the principal axis. Remember that this is a parallel one. This is still a straight line. Okay, I think it's still not straight, but I'll do that now. All right. Okay. So this is what we have, and this one will strike the mirror at 90 degrees and now goes back at the same path, right? Just like we have said before. So what are we seeing here? We notice that, remember that here is still F. We notice that the point where the image form is there, right? So, and the head of the image will be downwards, just like we have said before. So, you see that the image forms at where? At F. So, when the position of the object is from infinity, and you have intersection, image will form at where? F. Alright, so talking about the nature, what can we say? We say that it is what? Real and inverted. It is real and inverted. Then what of the size? What of the size? The size is actually diminished comparing to where it is coming from. Now we are going to appreciate this more when we carry out an experiment in the lab, which we might as well give an animation of what I mean as we later in this video. Now the position is at where? At F. The position is at F. Alright, so just take your time, go through this position of objects and see different properties of image that are formed with respect to those different positions, because it is important that you should know each of them, and you will know each of them by understanding how to draw the ray diagrams. And when you do that, everything will be at the tips of your hands. So I think we should be ending our class today so that you have your time to learn this we have already treated. So just watch the video and watch it again, and I will also forward assignments to you so that when we come back to our next class, we now look at the other objectives. So thank you and see you some other time. Bye. Yeah, so now I